This video is presented by third-year chemical engineering students from UTM to fulfill their corporate social responsibility. The topic for this video is leaching process in industry.
Leaching is the separation of solutes from solids using liquid solvents. It is done by bringing the solids in contact with a liquid solvent, so that the solvent could extract the solutes out of the solids. For example, the separation of soya milk from soya bean. Can you recognize this as a leaching process? Here, soya milk is the solute extracted from the solid phase, soya bean, by contacting the soya bean with the liquid solvent, water. Factors affecting the rate of leaching includes particle size, temperature, concentration or reagent and stirring rate. To add on, smaller particle size, higher temperature, higher concentration of reagent and higher stirring rate gives higher rate of leaching.
There are three types of leaching equipments: fixed bed leaching, moving bed leaching, and agitated solid leaching. Fixed bed leaching is used in processes such as beet sugar extraction, extraction of tanning extracts from tan bark and extraction of pharmaceuticals from barks and seeds. This figure shows a typical sugar beet extractor. Heated water at 344 Kelvin to 350 Kelvin flows into the bed to leach out the sugar. The leached sugar solution flows out the bottom onto the next tank in series. The top and bottom covers are removable so that the leached beets can be removed and a fresh charge added. For moving bed leaching, there are a number of devices for stage-wise countercurrent leaching where the bed moves instead of being stationary. These are widely used in extracting oil from vegetable seeds such as peanuts and soybeans. The solvents are usually petroleum products, such as hexane. The final solvent, vegetable solution, called miscela, may contain some finely divided solid. This figure shows the Ballman extractor, an enclosed moving bed bucket elevator device. Dry flakes are added at the upper right to a perforated bucket. As the buckets on the right side descend, they are leached by a dilute solution of oil and solvent called half miscela. This liquid percolates downward through the moving buckets and is collected at the bottom as the strong solution or full miscela. The buckets moving upward on the left are leached countercurrently by fresh solvent sprayed on top bucket. The wet flakes are removed continuously. Figure shows Hildebrandt extractor. It consists of 3 screw conveyors arranged in U-shape. The solids are charged at the top right, conveyed downward, across the bottom, and then up the other leg. The solvent flows countercurrently. Figure shows a countercurrent stage system for agitated solid leaching. Fresh solvent enters the first stage thickener as shown. The clear, settled liquid leaves and flows from stage to stage. The feed solids enter the last stage, where they are contacted with solvent from the previous stage, then enter the settler. The slowly rotating rake moves the solids to the bottom discharge. The solids together with some liquid are pumped as a slurry to the next tank. Application of leaching in daily life. Leaching happens every day in our daily life. The most common leaching process that you might have witnessed before is the brewing of a cup of green tea. From here we can see that the tea bag is our solid matrix. Green tea leaf flavor will be our desired substance to be extracted. Hot water is the liquid used to facilitate the ability to remove or extract the given substance from solid matrix. Finally, this results in a drinkable tea, solvent with dissolved flavors, with the completely depleted tea leaf residue, solid carrier phase, remaining in the tea bag. Now, we will discuss on the application of leaching in biological and food processing industry. The type of equipment used for leaching of sugar from sugar beets is the fixed bed leaching. In the leaching process, sugar beets are the solid materials. The desired solute that we want to extract is the sugar juice. Both of these are in contact with the liquid solvent, which is the hot water for leaching to occur. Sugar beet processing involving 6 steps. First, the sugar beets are harvested from the farm. Second, the sugar beets are washed and sliced to extract the juice and separate it from the plant material. Third, the juice is cleaned to remove impurities and extra color to produce the sugar syrup. Then, they are crystallized. Finally, the crystallized sugar is dried and packed for distribution.
Besides, the pharmaceutical industry is involved in leaching process. The products from pharmaceutical manufacturing processes are isolated using different separation processes such as leaching, and the products are sent to the formulation unit.
Next, metal processing industry also involved in leaching application. One of the examples is leaching of gold from its ore with aqueous cyanide solution. There are two types of gold leaching, which are heap leaching and vat leaching, or can be called as tank leaching. In vat leaching, the ore is mixed with cyanide solution in large tanks to extract the gold. In heap leaching, cyanide solution is sprayed over huge heaps of crushed ore spread atop giant collection pads. As it trickles through the heap, the cyanide dissolves the gold from the ore into the solution.
Lastly, the application of leaching process is phytochemical industry. Phytochemicals are chemical compounds produced by plants, generally to help them resist fungi, bacteria and plant virus infections, and also consumption by insects and other animals. For instance, vitamins A, C, E, and phenolic compounds found in plants, all act as antioxidants. In order to obtain the phytochemical from plants or herbs, leaching process is required in this process. Multiple solvents have been commonly used to extract phytochemicals, such as methanol, hexane, and ethyl alcohol. In this process, the antioxidant liquid in the inlet plant is dissolved by using the hexane solvent. Then, the enriched solvent will flow to purification section to obtain a pure antioxidant liquid.
Tongkat Ali is one of the leaching applications in phytochemical industry. First, Tongkat Ali root chips are sent to the extraction vessel to be extracted using the boiled water as a solvent. After the first stage of extraction, the extracted liquid is pumped and stored in a holding tank while the leftover chips are then extracted again using fresh solvent in the second stage of extraction. After the second stage of extraction, the solvent is removed and stored for reuse in the following batch and the leftover chips are discharged. The extract from the first extraction stage is sent to the spray dryer to produce Tongkat Ali extract powder.
As a conclusion, leaching is very important to extract a substance from a solid material by dissolving in a solvent liquid. Therefore, every engineer should know the whole process in leaching when dealing with separation between solid and liquid in future industries.